The title of this video is simply Learn More Math. We covered in a series of short videos the concepts from different fields of mathematics. And the aim was to get you ready for the research section of the channel. In the research section, we will have longer videos with more explanation with application in machine learning. We will primarily focus on the interplay of mathematics and machine learning. Subjects like information geometry, manifold learning, and using techniques from mathematics to enhance the latent space, expressivity, and capacity. In this video, I'm going to give you some more resources to study and have a good understanding. We started with manifold. You can find the resources in the description of the video. This short introduction starts with the definition of the chart and atlas, also the topological and smooth manifold, which we discussed in the manifold video. You can see that it is defining the conditions that we had on a torus. We used the sphere there. And it defines the boundary and etc. on the manifold. In order to have some interaction with you, I want you to have a look at this exercise, recognizing the manifold, and answer in the comment the question, which one of the following has a manifold structure? Like A is the arbitrary subset of Rn, B is the open set of Rn, a graph. Hawaiian airing are these weird looking functions. So through A to I, or maybe also the next page, which one of these you think has a structure of a manifold? So let me know in the comment and also ask me a question about these resources also if you have any. So please have a good look at these pictures and the definitions and tell me which one is the manifold. So in this short introduction we can see a lot of stuff like the tangent space that we defined, also the formal definition of the tangent space, what it means, how it is defined, and like other concepts like immersion, embedding, and etc., which we had a brief look also. So the power of the geometry is really becoming obvious in AI, and we are using it a lot. For learning like the subject, the introduction to a smooth manifold is the resource that is being taught and is the official resource. Also, these notes from the manifold by Dmitry Fuchs is also very interesting. These resources introducing are really short. They're like maybe 100 pages, so you can go through it easily. Again, we see the definition of manifold, local coordinate, chart, etc. Also, you can see as examples like Rn is an n-dimensional manifold itself. And it has this chart and also the sphere, how we can define a coordinate on the sphere, so it become a manifold also. And other manifold like Grassmann manifolds, which are interesting concepts also. And you can see other subjects. It's like 70 page this introduction. And we defined like differential forms also, and concepts from homology and cohomology, and concepts from Lie algebra like commutator and etc. You can find these concepts in this introduction also. So the concept of space and manifold are really important. I encourage you to have a good look We will use them in the research section more often, like in the hash theory and the manifold learning, and also for the latent space and etc. The next resource is an elementary introduction to group and representation by Brian Hall. Let's have a look at the subjects in this paper. It introduced the group, starts with the group and examples, subgroup, direct product, homomorphism and isomorphism. And it jumps to the matrix Lie group, definition of the matrix Lie group and some examples, and the concept from topology applied to the Lie group like compactness, etc. Then it begins with Lie algebra and the exponential maps. And we have like some basic of representation theory concepts here also, so you can see examples of representation, the irreducible representation, etc. Direct sum, which we had a look in the representation. This resource is also very nice, an introduction to Lie group and Lie algebra with application. This is a short paper, also an old paper. It starts with Lie group, Lie algebra and their structure, different kind of Lie algebra that we have, and the application, even in classical mechanics like. So it's nice always to see more application. And we have a good sense of what's going on with these abstract concepts. And I liked this part, the local structure of the Lie group is completely determined by the Lie algebra. This is a great importance in application. When local nature is being studied, we consider the Lie algebra. And this paper, Introduction to Representation Theory, it starts with the basic notation of representation, defining ideal, algebra, etc. And it goes into more depth as it goes forward. So, representation of finite group. This is the first step in representation theory. And it's like 100 pages, and it has a section about category also. So we had a video about category, the definition of category, functor, morphism of the functor, and etc. So it's really nice that you have a look at all of these concepts and read about them to be ready. Also, do not forget to like my videos and subscribe to my channel.